Hello everyone, so today we're going to be looking at a tutorial based on Tribonacci series. We're going to learn what the series itself represents, what it is, and how to code for it in Java and how to code for it in MIPS. So as I did with my previous tutorial on Delano numbers, I'll provide this tutorial in 3 segments. So the first segment would be explaining what a Tribonacci series is. You should be able to skip it to directly go to the Java code of Tribonacci series. Also, if you don't want to see that and go directly into the MIPS coding of it, you should be able to do that using this timeline. So let's move on to the first segment of the video, which will be explaining what the Tribonacci series is. So the Tribonacci series is basically a series of numbers, and each of the numbers there represent 3 numbers that are before it, the summation of 3 numbers that come directly before it. So obviously there has to be the start of a series, and at the start you don't have 3 numbers before to add them, you don't have 3 numbers prior to the number you're looking at to be able to add them up and get the number. So we always start the Tribonacci series with 3 numbers. Now I've seen throughout the internet there are some variations of it, and the one I've seen most commonly used is the series starting with 0, 1, 2. I've also seen variations like 0, 1, 1 and 1, 1, 1. But in this tutorial we're going to be focusing on 0, 1, 2, as that is the more commonly, the common series that I've seen throughout the internet. So the series basically looks something like this. It starts with 0, 1, 2, as you can see right here. 0, 1, 2, and then you go on ahead to 3. How do you get 3? By adding 0, 1, and 2. How to get 6? By adding 1, 2, and 3. How to get 11? You get 2, 3, 6. And so on. It can go infinitely long. You can carry out the series for as long as you want. There's no length fixed for it. You can go at it infinitely. So like here we have 8984. The next term of the series would be 8984 plus 4841 plus 2632. Whatever the addition of that provides would be the next term of the series. So to review it briefly, the first 3 terms would be 0, 1, 2, and all of the terms that comes after it is basically a summation of the 3 terms that are prior to it. So let's move on to the next segment of the video, the second segment, which will be explaining how to write the Java code for the Tribonacci series. So if you return to our Eclipse interface, we can see that I've already written the Tribonacci series code right over here. So we've kept it under package Tribonacci class solution like before, and as always, this is a Java code. You can easily convert it to a C code. The main public static void main would be converted to int main, and this won't be needed. This will become a scanf, which will save the term at A, and then we'll print whatever the output is at Tribonacci. I've also added a for loop to make it easier for you to see what all of the outputs are, not just one output in particular. And by the way, the input that we're storing at A is basically the number, the nth term that we want for the Tribonacci series. So let's say we give 10, it should be able to give the 10th term of the Tribonacci series. In for the for loop, it'll give you all 10 terms that exist for the Tribonacci series. Actually, there is a particular difference that I would like to point out before moving on to the code. We've started the code from 0, so if you notice something, let's keep it short. Let's say I give 3 as an input. It gives 4 terms, so you get 0, 1, 2, 3 for this particular series. So if you want actually to change that, let's say you want just to get, like if I give an input 3, you want the 3 terms, you can just write -1 here. That does it easily. And afterwards we give, I have to build it up. Okay, so now if I give the input 3, it shows you 3 terms, 0, 1, and 2. Also, if I now write 10 or 16 as I previously written, or 15, let's just keep it 10, you can see there's 5, 10. There are 10 terms that are presented here, and the 10 term is 1, 2, 5, and which is also being shown right here. So the code for Tribonacci, the function or method for it is basically it takes an integer as an input, and once it gets the integer, it checks if it's 0. If it's 0, it returns 0. If it's 1, it returns 1. If it's 2, it returns 2. And if it's none of the above, then what it returns is basically it calls the function again, sends n-1 into it, it calls the function again, sends n-2 into it, and it calls the function again and calls, puts n-3 into it and adds them. Once again, if you understand recursion, this code should be very simple to understand. It just keeps subtracting the parameter and until it gets to one of these three numbers, and once it gets to those numbers, it just basically adds them all up to get the new number. Okay, so that is all for the Java code, and I will also, like I did with the previous tutorial, I'll try to provide the code file or the code itself in the description. And so let's move on to the third segment of the tutorial, that is going to be the MIPS coding. So I've already loaded up the MIPS coding for the Tribonacci series, and as you can see here, we have the main labeled again. We're putting 10 as a parameter into it, so we're going to basically get the 10th term and this after running this file. I already have comments again. I actually did this previously, so let me remove the comments. Yeah, that was all of it. So yeah, so this is our Tribonacci series, and we take 10 as an input. We call the function Tribonacci. Once we have 10 as a parameter, a0 is a parameter register. So we go to the Tribonacci function. Once it returns a value, we exit by going here. Otherwise, we'll just keep calling the function again and again, which will make it an infinite loop. So we exit right after this. So the Tribonacci function, what it does is this time we make room for 3 integers, 3 numbers. So basically as all integers take 4 bytes of space, we make space for 3 integers. We're making 3 into 4, 12 bytes of space. So we subtract 12 from SP, the stack pointer. We store return address at the 0 offset of the pointer, and then we store at the next pointer, at the next spot, we store a0, which is our parameter, and then we store 0 as a return value. We check if it's not equal to 0. If it is not, we go to check 1. So check 1 checks if that is equal to 1, if not equal to 1. If that is true, we go to check 2, and then we go to recursive. Now if any of these not equals become false, that means this is 0, so we go to base case 1. That is the first base case, which will be for n equal to 0. If you remember the code, for n equal to 0 to return 0, so we make the value 0. We first load up the return address from the stack, we add 0 into the v0, the return value, and we basically store that in the stack pointer in its designated place, that is 8th offset of the stack pointer. And then we add up 12 because we do not need that segment of the stack anymore, and then return to the return address that we loaded right here. But if it isn't 0, we go to check 1, we check if it's 1, if it's 1, if it's not 1, we go to check 2. If it's 1, we jump to base case 2 right here. So base case 2, what it does is it does the same thing that the base case 1 does, only the difference being that here we put 0 in v0, we're putting 1 in v0 this time. The rest of it is the same. So if it wasn't 1, if it wasn't 0, if it wasn't 1, we check if it isn't 2, in which case we go to recursive. But if it is 2, we go to base case 3. We don't have to jump because we can write it immediately down below this statement. So afterwards we put 2 in the v0, the rest of it the same as the other base cases. And after that we go to recursive. I mean, if it's not 0, 1 or 2, we jump to recursive, which what it does is basically just subtract 1 from it and call Tribonacci, which is actually the first segment of it, n-1. So it does that, and we get 1 subtracted. So for example, if we entered 5 here instead of 10, it'll go right to recursive because it's not 0, 1 or 2. So we get to 5, that is here that it comes here, so 5 minus 1 becomes 4. Once again it's not 0, 1, 2, it comes here again, becomes 3, then 2 matches with this check, so it actually goes to basically 3, and we return a value of 2. After that, after setting the value of 2, when we jump to the return address, it actually got called from here last, so the return address is actually this one, 42. From there on, we load up the return value from the stack pointer that we already have in the segment. We add v0 to it. We save that one up into the 8th offset of the stack pointer. After that, we load up the parameter from there, subtract 2 from it, and call Tribonacci function again, which is actually this segment right here. We have subtracted 2 from the parameter originally, and so from that segment, when we subtract 2 from it, we get another parameter for that calling, and we go to Tribonacci, we save that value again over here, we check what it is. So basically, after that, once we've done its part over there, like, you know, subtracting and everything all together, what we do is we come to, when we go to the GRRA, return to the return address, we come to this point where we once again load and add them up. This time we subtract 3 from the parameter, which is actually this part, which deals with that value particularly, and then we go to this return address, actually to 56. So from there on, we actually load up the return address. We after that, because we're loading the return address because we're going to be returning again from here, so we need to load the return address that was stored in this segment particularly. After that, we save the value of the T0 register, we add V0 to it, we then load it to the 8th offset, we save it there, and then we add 12 to it because we do not need that segment anymore. After that, we return to the jump and return to the return address that's loaded there. At some point, this will become the original calling return address, which is going to be this one, where we jump to the exit, which brings the flow to the exit label, and our code finishes. It's a fairly simple code. It isn't actually complicated, which is why I actually paced through it quite fast rather than taking it too slow, because if you actually run through it, if you simulate it like I've shown you in the previous tutorial, you can just save it. You know, you have to save the code at MAS, you have to run and assemble. If you go step by step, you can actually see the flow, see the changes. Notice here we subtracted 12 from the SP, so the value got subtracted by 12, and at that address we stored the return address of, where it was called. So the return address was 4194312. We got 4194312 right here. After that, we store the parameter, which is A0 at 4 SP, which when we run that line, we get 10 because we had 10 in the parameter. Then we store 0 there, and it goes on. It checks all of them at recursive. It subtracts 1 from A0. It becomes 9 here. Hold on. See, it becomes 9 here, and then the stack pointer gets subtracted by 12. You store all of those values, and then you have this previous segment and the next segment, and it goes on. At the 10th, if you run the whole code, what we get at V0 is 230. If you notice here, hold on. So if you put 10 here, we actually get 125 because we did a minus 1 previously. But if you keep the value a, that is basically for 10 seconds. Actually, as we're starting from 0, it'll actually go to the the 11th value. So what we get is 230. So we're not counting the 0, we're taking that as a 0. So we go 1 2 3 4 5 6 7 8 9 and then 10. That is 230. So our input is right. We can also check it for other values, so we could go for, let's say, 5. So we save that, we run that, we run it completely, and at V0 we have 11. If you check it with the series, 0 1 2 3 4 5, so yeah, it's 11. So that's what it is. I would definitely recommend that you run it through step by step and check the simulation. It's really difficult to explain all of it step by step. The video will already, which is already large pretty much, will become so much larger, and the explanation gets tedious to watch even. It's better if you just, click on this button, check step by step what happens. As you can see, the stack grows. The stack also shifts the pointer at some point and changes the value. You can see the 0 became 2 right here, and that's actually the part where I told you that it becomes 2, and then it goes on, and you can check what happens to the values and how the final result, that is in this case for an input of 5, the 11 at v0 comes 2. Okay, so that is it for the Tribonacci series tutorial, and once again, if you have any questions, you can ask me in the comments. I will try to answer them as soon as possible, as soon as I get time and I log in and I see them. Also, if you have anything else to say about the tutorial, you can say it in the comments, and I will try to provide the files, the ASM file, which is basically the MIPS coding file, and the Java file for the Java coding, into my description. I will try to provide them so you can, run them and try them yourself. So that is it for the Tribonacci series tutorial. See you all next time. Thank you.